Hello, this is Tyagarajan. Welcome to my channel. In this video, I am going to discuss how to solve some simple problems asked based on the cache memory. I will explain how these problems may also be asked as multiple choice questions. In any computer system, CPU will be at the highest level, then in the first lower level, cache will be present, and in the second lower level, main memory will be present. If CPU wants any data, first it will request the cache, and there it will be decided whether the data is available or not. For that, it will take some time. If it is available, then it is called as hit. If there is a hit, then that particular data will be searched within that cache and it will be retrieved and it will be issued to the CPU. For searching the data within that memory, it requires some time and that time is called as access time. To search the data within that memory and bring it out, the cache takes some time. That time is called as cache access time. If that data is not available, then it is called as cache miss. In that case, that particular data will be available in the main memory. So, a memory request is issued. If the data is available in the main memory, then it is called as memory hit. If the data is available within that main memory, then that particular data will be searched in the memory. It will be retrieved and it will be issued to the cache. To search and retrieve, the main memory requires some time. That time is called as memory access time. This is also called as memory hit time. The memory hit time is almost same as cache miss time. If you know these basics, then you will be able to solve any problem asked in this topic. In short, we can say that if the data is requested by the processor and it is available in the cache, then it is called as hit. If the data is not available in the cache, then it is miss. Then how to calculate the hit time? It is the time needed to decide whether the access is hit or miss plus time taken to access the cache. That is the access time of the cache. The miss penalty is nothing but the extra time required to bring the data from the main memory to the cache. Now let us see the first MCQ. Generally, dynamic RAM is used as main memory in a computer system as it consumes less power, has higher speed, has lower cell density, needs refreshing circuitry. Dynamic RAM needs refreshing circuitry, but it is not an advantage. It has high package density, so C is also not correct. Then it has higher speed. Actually, its speed is less than the static RAM. So this is also not correct. It consumes less power. So this is correct. So the correct answer is A. Let us see the next one. Cache memory acts between, from the diagram you will be able to identify. Actually, the options are given like this: CPU and hard disk, main memory and hard disk. This is also not correct. CPU and main memory. This is correct. D is also not correct. So the correct answer is C. Let us see the next question. The performance of the cache memory is frequently measured in terms of a quantity called miss ratio, hit ratio, latency ratio, and read ratio. C is the correct answer, latency ratio. The next one is, if the program is available in dash, it may not be executed directly by the CPU. If any program is to be executed, then it should be available in the main memory or cache. Primary cache, secondary cache, main memory, secondary memory. If it is available in secondary memory, then it may not be executed. It should be brought to main memory first, then it should be brought to secondary cache, then from that it should be brought to primary cache. But in some computer systems, even without cache, the program will be executed if only main memory is there. If the program is in the secondary memory, it may not be directly executed. So D is the correct answer. In some problems, you will have to find out the hit rate or hit ratio, then miss rate or miss ratio. The hit rate or hit ratio is nothing but total number of cache hits divided by total number of requests. The total number of requests will be equal to the number of cache hits plus the number of cache misses. If you need the percentage of cache hit rate, then hit ratio is equal to hit rate into 100. You have to multiply this value by 100. The miss rate is calculated as the ratio between the number of cache misses to the number of requests. You should also remember that if the hit ratio is 0.8, then miss ratio will be 0.2. That means the miss rate is equal to 1 minus hit rate, or you can say that the hit rate is equal to 1 minus miss rate. Now let us solve some problems in hit rate and miss rate. A cache has 47 cache hits and 3 cache misses over a period of 2 seconds. The hit ratio is A 0.94, B 0.47, C 0.936 and D 0.06. Anyway, we have to solve this and choose the correct answer or correct option. So the hit ratio is given by number of hits divided by number of hits plus number of misses. Here the number of hits are given as 47 and number of misses 3, but you need not worry about the time because the hit ratio is not calculated per second. The hit ratio is calculated over a period of time. So it may be 1 second or 2 seconds or 1 minute. It may be anything. But you have to find out the ratio of how many hits happened and how many requests happened during that time. So here number of hits is 47, then number of hits plus number of misses will be 47 plus 3. So 47 by 50. That is the correct answer. That will be equal to 0.94. So A is 0.94. So the correct answer is A. Similarly, you see this problem. A cache has 47 cache hits and 3 cache misses over a period of 2 seconds. The same problem I have asked, but here you have to calculate the miss rate. So the miss rate is given by number of misses divided by the total number of requests. That means number of hits plus number of misses. Here number of misses is 3. So 3 divided by 47 plus 3, that will be equal to 0.06. So D is the correct answer, 0.06. Now if you observe these two answers, the hit ratio is 0.94. So the miss ratio is 1 minus 0.94. That means 0.06. You should understand that the sum of the hit rate and miss rate will be equal to 1. Anyway, in this case, the correct answer is D. If the content of this video is useful, please press like button and share to your friends or students who are studying engineering. The hit rate helps to know how many cache accesses become hits in a specified time. But the average memory access time tells you how fast the access happens. The hit time is the time taken to access the data when it is available in the current level of memory. For example, if the data is to be accessed from the cache, the current level of the memory is cache. So if the data is available in the cache, then the time taken to get the data is cache hit time. If it is not available in the cache, then it is a cache miss. So the miss time is nothing but the time taken to access the data if it is to be brought from the next level of memory. Next level means here it is the main memory. It is nothing but hit time of the cache plus miss penalty. Miss penalty means the time taken to get the data from the main memory and place it in the cache. So the average memory access time is equal to the total time spent on hits plus the total time spent on misses. That is equal to total hit time plus total miss time. The total hit time is given by hit rate into time per hit. Then total miss time is given as miss rate into time per miss. Now let us see a simple problem. The memory access to main memory on a cache miss takes 30 nanoseconds and a hit takes 3 nanoseconds. If 80% of the processor's memory requests result in a cache hit, what is the average memory access time? The options are given like this. In this case, you should understand that cache miss is also happening. In that case, the data should be brought from the main memory. So when hit happens, the data is available in the cache and it should be brought from the cache to the CPU. So it takes minimum time. That time is given as 3 nanoseconds. nanoseconds. If the data is not available in the cache, then it is a miss. So in that case, the data should be brought from the main memory. So the total time required to get the data is the time taken to bring the data from the cache and the time taken to get the data from the cache. So it takes maximum time. That time is given as 30 nanoseconds. So the minimum time required to retrieve a data is 3 nanoseconds and maximum is 30 nanoseconds. In that case, 2.4 nanosecond is not correct because it is less than the minimum time. Similarly, 35.4 nanoseconds is also not correct because it is more than 30 nanoseconds. So the average memory access time may not be greater than 30 nanoseconds. At the same time, the minimum access time may not be less than 3 nanoseconds. So the average memory access time will be somewhere between 3 nanoseconds to 30 nanoseconds. So anyway, E and F are not correct. You can omit. So from the remaining options, you have to choose the correct one. For that, you have to calculate the memory access time. It may be calculated like this. If 80% requests are hit, then the remaining 20% requests are miss. So hit rate is 80 divided by 100 and miss rate is 20 divided by 100. The average access time is equal to hit rate into time per hit plus miss rate into time per miss. Hit rate is 80 divided by 100. Hit time or time per hit is 3 nanoseconds plus miss rate is 20 divided by 100 into miss time is time per miss, that is 30 nanoseconds. So this will be equal to 2.4 nanoseconds plus 6 nanoseconds, that will be equal to 8.4 nanoseconds. So the correct answer is 8.4 nanoseconds, that is D. Let us see another problem. In a processor, a read request takes 50 nanoseconds on a cache miss and 5 nanoseconds on a cache hit. If 80% of the processor requests results in a cache hit, the average read access time is dash nanoseconds. The options are given like this. So actually hit time indicates the minimum access time. It is 5 nanoseconds. Miss time indicates the maximum access time. That is the time required to bring the data from the main memory. It is 50 nanoseconds. So the average access time may not be less than 5 nanoseconds and may not be greater than 50 nanoseconds. So in the given options, C is greater than 50, so it is not correct. And E is less than 5. This is also not correct. So you have to choose one from the remaining options. Anyway, there is no shortcut. You have to solve the problem and find out the correct answer. If 80% requests are hit, then the remaining 20% requests are missed. So hit rate is 80 by 100 and miss rate is 20 by 100. The average access time is hit rate into hit time plus miss rate into miss time. Hit rate is 80 by 100. Hit time is 5 nanoseconds. That is the time required to access the cache. That is 5 nanoseconds. Then miss rate is 20 by 100 and miss time is 50 nanoseconds given here. So if you calculate these values, you will get 4 nanoseconds plus 10 nanoseconds, that is 14 nanoseconds. So the average read access time is 14 nanoseconds. So the correct answer is B. If the content of this video is useful, please press like button and share to your friends or students who are studying engineering.